last video, we discussed that protons, neutrons, and electrons aren't the only things that make up the universe. Actually, there's particles that are smaller than them. Now, this video is really important, so make sure you take notes from this video, and you need to learn basically this mind map that I'm going to draw out here. It looks complicated at the start, but watch the video again and replay it, and it's not that difficult once you've kind of watched it a couple of times. So let's just focus on what the universe is made of, and the universe is made up of mostly matter. Now, any particle that contains matter is known as a fermion. All particles with matter. So basically every particle I'm going to discuss today is a fermion, because there are energy particles as well, but this is just matter I'm talking about today. Now, matter is made up of two different sections. The first section are known as hadrons, and hadrons come from the Greek word meaning heavy, so these are the bigger particles. And the second section are called leptons, which I think, I'm not 100% sure, come from the Greek word meaning light, so these are the smaller particles. Now, the thing about leptons is leptons are all what we call fundamental particles. And fundamental particles means they're made up of nothing else. They are what they are. They're not comprised of smaller particles again. So these are fundamental particles. Whereas hadrons are not fundamental. They're made up of smaller particles. Made up of smaller particles. So that's the first difference that you need to know between the two of them. The next difference that you need to know between the two of them is what forces they experience. So hadrons experience or feel all four forces of nature. So in the first lesson on this chapter, we talked about the four forces of nature: gravitational, electromagnetic, strong nuclear, weak nuclear, and hadrons experience all of them. Leptons do not. Leptons experience them all, except they do not experience the strong nuclear. Now, that doesn't mean too much to you at the moment, but again, this all becomes clear as we go deeper and deeper into the chapter. But they do not experience the strong nuclear is what you need to learn. So now, that's the main bit. You want to make sure you're happy with that bit first of all, the difference between hadrons and leptons. Now let's look at hadrons in a little bit more detail. Am I not right on this? Sorry, when I zoomed out, it kind of messed everything up. Try again. Okay, so now hadrons. Hadrons are made of two different types as well. So we've leptons and mesons. We're just going to look at hadrons now. Hadrons are made up of, oh no, the pen's all messed up. That's a bit better. Right, we'll try once more, sorry. Hadrons are made up of two parts as well. They're made up of baryons, and mesons. So baryons are made up of three quarks or three antiquarks. So it's either three quarks or three antiquarks. There's not a mixture of quarks and antiquarks. And you actually know some baryons already. you know about protons, and we talked about them in the last lesson. Protons are made up of an up quark, and a down quark. Neutrons, they're a baryon. They're made up of an up quark, a down quark, and a down quark. And two other ones that you won't have heard of before are the lambda particle and the sigma particle. So there are other examples of baryons, and you come across these in questions and they kind of give you the information you need to solve them. So you don't need to know the quark composition of lambda and sigma. The next type are mesons, and mesons are made up of one quark and one antiquark. So it's one of each, one quark and one antiquark. So you've never heard of these particles before, but one example is known as the pion, and pion is actually short for pi meson, that's what it's called. And there's different types of these. There's a plus pion, which has the symbol pi plus. There's a negative pion, and there's a neutral pion. But the pion, or the pi meson. Another one is the kaon, and again there's a negatively charged kaon, a positively charged kaon, and a neutral kaon. So they're the examples of mesons. Now you just need to know kind of general examples of each one. But the key bit here is understanding that mesons are made up of one quark and an antiquark, and baryons are made up of 3 quarks or 3 antiquarks. So sometimes they kind of say baryons are the biggest, mesons are the middle particles, and then leptons, which we're going to look at next, L, are the lightest or the smallest. Now, in terms of fundamental particles, because that's important, you want to know what the fundamental particles are. A baryon and a meson are not a fundamental particle because they're made up of smaller particles. But the quarks and the antiquarks, they are the fundamental particles. So all the things on the table I talked about last lesson, your up, down, strange, charm, top, bottom, they're all fundamental particles. So now let's go over and have a look at leptons. Leptons are easier to remember because they're fundamental. These aren't made up of anything else. And there is 6 leptons. The first lepton you've heard of is an electron, fundamental, not made up of anything else. The next lepton is known as a muon, which has the symbol mu. Next lepton is known as the tau particle, which has this kind of Greek letter tau. And then what are known as the neutrino particles. So each lepton has a neutrino particle as well. There's a particle called the electron neutrino, and they all have a symbol V and then E for electron neutrino. The muon neutrino, and that's V with a mu sign, and then the tau neutrino. And they're the 6 lepton particles. Now, as I said, like with quarks, where you have your up quark and then your anti-up, it's the same with electrons. There is also, so you have 6 leptons, but you also have their anti-leptons as well. 6 leptons, sorry, you have their anti-leptons. So you have the anti-electron, the anti-muon, the anti-tau, the anti-electron neutrino, anti-muon neutrino, and anti-tau neutrino. So there is 12 more fundamental particles. Okay, so all of this information is on page 377 of your textbook, and it's a lot of information to learn and take in. But watch the video a couple of times. I really do watch it a few times. And then also read the pages in your textbook. I'll put a bit of more information up on Teams. And then that's what I want you to learn today.